Installing conductors in parallel requires careful consideration, especially regarding raceway selection. Using dissimilar raceways, such as EMT with RMC or IMC, can lead to several problems. Firstly, different thermal properties can cause issues. EMT exhibits low thermal conductivity compared to RMC or IMC. This means EMT dissipates heat less effectively. Consequently, conductors within EMT may overheat, potentially damaging insulation and creating fire hazards. Secondly, variations in magnetic properties can arise. RMC and IMC are magnetic materials, while EMT is not. The magnetic field generated by current flowing through conductors in RMC or IMC will be stronger than that in EMT. This difference in magnetic field strength can interfere with nearby electrical equipment like transformers and motors. Thirdly, corrosion resistance differs among raceway types. RMC and IMC offer greater corrosion resistance than EMT. Conductors housed in RMC or IMC are less susceptible to corrosion, potentially extending the installation's lifespan. The National Electrical Code, or NEC, emphasizes the importance of using raceways with equivalent impedance when installing conductors in parallel. This requirement aims to ensure balanced current distribution among the parallel conductors. If the raceways exhibit significantly different impedances, one conductor may carry a disproportionately larger share of the current. Such an imbalance can lead to overheating and premature failure of the overloaded conductor. The NEC addresses parallel installations in Section 310.10. Section 310.10 home permits conductors size 1/0 and larger to be run in parallel and requires that they be the same length, conductor material, circular melt area, insulation type, and be terminated in the same manner. Section 300.20b covers parallel conductors and requires that where conductors are installed in separate raceways or cables, the raceways or cables shall have the same electrical characteristics. Conductors installed in parallel must follow specific guidelines outlined in the NEC to ensure safety and proper operation. All parallel conductors must be of the same length, conductor material, cross-sectional area or circular melt area, insulation type, and be terminated in the same manner. The code also mandates that if installed in separate raceways or cables, these raceways or cables must possess the same electrical characteristics. This includes factors such as impedance and material composition to ensure equal current distribution. Consider an installation with 3 500 kcmil copper conductors are run in parallel to supply a load. If one of the raceways has a higher impedance than the other two, it will impede the current flow in that conductor. The other two conductors will carry a larger share of the load current. This imbalance could potentially overload those two conductors, leading to overheating and insulation damage. In practice, this means avoiding combinations like running one set of parallel conductors in steel conduit and another set in aluminum conduit, or using different trade sizes of conduit for each set of conductors. Instead, use the same type and size of raceway for all parallel conductors to maintain consistent impedance. When conductors are installed in parallel, each conductor carries a portion of the total current. For instance, if a circuit requires 300 amps and two conductors are run in parallel, each conductor should theoretically carry 150 amps. However, if the impedances of the parallel paths are not equal, the current will not divide equally. The conductor in the lower impedance path will carry more than 150 amps, while the conductor in the higher impedance path will carry less. This uneven current distribution can cause the conductor with the high current to overheat, potentially leading to insulation failure and creating a fire hazard. The goal of equalizing impedance is to ensure that each conductor carries its fair share of the current, preventing any one conductor from being overloaded. The NEC allows for some flexibility in raceway materials, but generally requires that they be of the same type. For example, all raceways must be either metallic or non-metallic. Mixing metallic and non-metallic raceways in a parallel run is not permitted due to the significant difference in impedance and heat dissipation characteristics. Understanding the reasons behind the code requirements for parallel conductor installations is crucial for ensuring electrical safety and reliability. Using raceways with the same physical characteristics is not simply a matter of aesthetics. It's a critical factor in maintaining balanced current distribution, preventing overheating, and minimizing the risk of electrical failures. In addition to thermal properties, magnetic properties, and corrosion resistance, consider also the practical aspects of installation. Mixing different types of raceways can complicate the installation process, requiring different tools and techniques for each type. This can increase labor costs and the potential for errors. Furthermore, dissimilar raceways may have different expansion and contraction rates in response to temperature changes. This can lead to stress on the conductors and connections, potentially compromising the integrity of the installation over time. When designing a parallel conductor installation, select raceways of the same type, size, and material. This ensures consistent electrical characteristics, simplifies installation, and promotes long-term reliability. Adhering to the NEC guidelines for parallel conductor installations is essential for protecting people and property from electrical hazards. The physical characteristics of the raceways, such as size and construction material, affect the impedance of the circuit. The code requires that the electrical characteristics of the raceways be the same. This is best accomplished by using the same type of raceway throughout the run. Consider the scenario where one run of conductors is in steel conduit and another is in aluminum conduit. Steel has a higher impedance than aluminum. This would result in an unequal distribution of current. The conductors in the aluminum conduit would carry a larger share of the current, potentially overloading the conductors in the aluminum and starving the conductors in the steel conduit. This could result in a dangerous situation. The NEC is very specific regarding the requirements for parallel conductors. For example, NEC section 310.10 H2 allows for adjustment factors for parallel conductors in a single raceway or cable to be applied to the sum of the ampacities of the parallel conductors. The adjustment factor is used where there are more than 3 current-carrying conductors in a raceway. Where adjustment factors are required, the allowable ampacity of each conductor shall be reduced. These requirements apply to conductors in parallel. Using different raceways for parallel conductors can also affect the overall inductance and reactance of the circuit. The inductance of a circuit is a measure of its opposition to changes in current, while reactance is the opposition to alternating current due to inductance or capacitance. If the raceways have different magnetic properties, they can influence the inductance and reactance of the circuit, leading to voltage drops and other performance issues. For instance, steel conduit has a higher permeability than aluminum conduit, which means it can concentrate magnetic fields more effectively. This can increase the inductance of the circuit, leading to a larger voltage drop and reduced power factor. Therefore, using the same type of raceway for all parallel conductors helps to maintain a consistent inductance and reactance, ensuring optimal circuit performance. The NEC also requires that all equipment grounding conductors be run in parallel with the circuit conductors. This is to provide a low impedance path for fault current to return to the source, which helps to quickly trip the circuit breaker or fuse and prevent electrical shock. If the raceways have different electrical characteristics, it can affect the impedance of the equipment grounding conductor, potentially reducing its effectiveness. Using the same type of raceway for all conductors, including the equipment grounding conductor, ensures that the fault current path is as low impedance as possible, providing maximum protection against electrical shock. In addition to the NEC requirements, there are also practical considerations to keep in mind when installing parallel conductors. Using the same type of raceway for all conductors simplifies the installation process, as it eliminates the need to use different tools and techniques for each type of raceway. It also reduces the risk of errors, as the installer only needs to be familiar with one type of raceway. Furthermore, using the same type of raceway can improve the appearance of the installation, as it creates a more uniform and professional look. It is important to note that the NEC is not the only standard that applies to parallel conductor installations. Other standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA, may also provide guidance on this topic. These standards may cover topics such as the selection of conductors, raceways, and other equipment, as well as the installation and testing of parallel conductor systems. It is important to be familiar with all of the applicable standards before designing and installing a parallel conductor system. When selecting conductors for a parallel installation, it is important to choose conductors that are rated for the voltage and current that they will be carrying. The conductors must also be suitable for the environment in which they will be installed. For example, if the conductors will be exposed to moisture or corrosive chemicals, they must be rated for wet or corrosive locations. The size of the conductors must also be chosen carefully to ensure that they can carry the required current without overheating. The NEC provides tables that list the ampacity of different sizes of conductors. These tables take into account the type of insulation, the ambient temperature, and the number of conductors in the raceway. It is important to consult these tables to ensure that the conductors are properly sized. When selecting raceways for parallel installation, it is important to choose raceways that are suitable for the environment in which they will be installed. The raceways must also be large enough to accommodate the conductors. The NEC provides tables that list the maximum number of conductors that can be installed in different sizes of raceways. It is important to consult these tables to ensure that the raceways are properly sized. The NEC requires that all parallel conductors be terminated in the same manner. This means that all of the conductors must be connected to the terminals using the same type of connector and the same torque. This ensures that the current is distributed evenly among the conductors. It is also important to ensure that the connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to electrical fires. After the parallel conductor installation is complete, it is important to test the system to ensure that it is working properly. The test should include a visual inspection to check for any damage or defects. The test should also include an electrical test to verify that the conductors are carrying the correct current and that the voltage drop is within acceptable limits. The testing should be performed by a qualified electrician. In summary, installing conductors in parallel requires careful planning and execution to ensure safety and reliability. The NEC provides detailed guidelines on this topic, covering aspects such as conductor selection, raceway selection, termination methods, and testing procedures. By following these guidelines, you can minimize the risk of electrical hazards and ensure that the parallel conductor system operates effectively. The requirement that raceways have the same physical characteristics ensures a balanced system. The consistent thermal properties are important for heat dissipation. Similar magnetic properties prevent interference. Uniform corrosion resistance ensures longevity. Dissimilar raceways can create imbalances. These imbalances can lead to overheating. Overheating can damage insulation. Damaged insulation poses a fire hazard. Mixing raceway types complicates installation. Complex installations increase labor costs. Errors are more likely with mixed raceways. Consistent raceways ensure balanced current. Balanced current distribution prevents overloads. Overloaded conductors fail prematurely. NEC Section 310.10 details parallel conductor rules. Same length, material, and termination are required. Electrical characteristics of raceways must be the same. Use the same type and size of raceway. Consult the NEC for specific requirements. Adhering to the code ensures safety. Consider thermal and magnetic properties. Consider corrosion resistance. Consider practical installation aspects. Selecting the correct raceways is important. Select conductors rated for voltage and current. Select conductors suitable for the environment. Choose raceways that fit the conductors. Terminate all conductors the same way. Test the installation after completion. A visual inspection is always needed. An electrical test is also needed. Consult relevant standards like IEEE and NEMA. Pay close attention to the equipment grounding conductor. Do not compromise on safety.